my name is Emily Merritt, and today I'm going to be talking about my senior project, the MasterCap Automatic Rotary Capping Machine. I'll be going over slides 8 through 14 and 26 through 29. Let us begin with the electrical components of the machine. When my group was assigned to work on this machine, there was no power going to it. The entire power cord was gone. We talked with Professor Maged in order to get a new cord to be able to work on the machine. Once we got the new cord in place, the machine started to have power going to it. Sadly, it was only going to a portion of the machine. So we began physically tracing the wires to see where it might have been wired wrong or to find out if something was maybe mislabeled. After talking with Professor Higley, we were given a local engineer's contact info named Jared Goodall. Jared helped us find and fix our power problem. Turns out that since the automatic cap feeder was not installed on the machine due to the spacing in the building of CMAC, it would create too much of a height difference and they would have had to take some of the ceiling out for it to work. The door sensor on the back was still connected and wired, but it was saying that it was open. And so to stop, and that was causing the power to not go to the rest of the machine. So to stop that from happening, we had to rewire the door sensor to make it say that it was normally closed instead of saying normally open. Thankfully, we had his help because we realized we had actually made a mistake. We had started the rewiring process, but only rewired one of the yellow connectors points, as you can see on there in the picture, which is of the door sensor. And we managed to, with his help, figure out that we needed to fix that part. We initially thought that just rewiring the door on the back end of the machine was going to be good enough for the power to get through, but with Jared's help, we were able to realize that we also had to rewire a part inside of our main control box 1, to get it to actually allow the power to get through to the rest of the machine and the safety relay to turn off so that the rest of the machine could move. Jared Goodall's contact information can also be found here on this slide. That way, so if you need to get in contact with him to find out more information about what he's helped us with, this is it. We managed to get the PLC program off of the machine, but we had to manually set the air pressure sensor to read that it was activated. This was due to the fact that there was a problem with the air hose originally connected, leaking air and pouring it out onto the floor instead of into the machine. That rung was in our ladder logic 4, rung 0000, and the binary file 2-12 set to the value of 0 is how we got that to work. This is a picture of the ladder logic LAD4, which shows where the air had to be turned on. It can be seen at the top right corner where you can see in red where we had to automatically make it so that it would run. When it comes to the HMI program, not much is known. This is due to the fact that the HMI is password locked. The school does not have the password, and the HMI installed on the machine is a Bayer E300 HMI. We did end up contacting the Bayer support to see if they knew any way that we could get the program off of the HMI screen, and they had told us that if we didn't have the original program, there was no safe way to get it off, because if the way that we would have had to go about it would possibly delete the original program on the machine. This is our original budget that we created in the course ET 495, which is Senior Project Survey 1. At the time, our total for our machine estimated cost was about $531.99. This is our final budget that we've created throughout the semester. Sadly, we weren't able to get the prices on the belts 100%. We were still waiting on feedback from Professor Rickerson, and we did come up though so far with our total of $90.79. This is our original schedule that we created in the course ECET 495 last semester. This was our expected schedule for the project. Originally, we were hoping to complete everything by the certain deadlines that we had set. This is our final schedule. Sadly, because of the coronavirus that is taken over the world right now, we are unable to finish our project by the deadline that we had originally set. But this schedule shows that we were originally on track to finish. You can see actually that when our parts were being ordered and being put on the machine all stopped around week 10. That's about the time when they started shutting our school down and forcing us to leave the premises and going home. We're hoping that we have enough information that if another group is put in charge of this project, that they will be able to finish it in time next time. We did manage to complete quite a few things that we had planned, but we were hoping to do more.